So about password attacks, we can approach password attacks from this perspective. Password attacks essentially target passwords. So the attacker will be interested in the files on your computer or operating system where passwords are stored. And they'll be looking for means to be able to recover the password, or better still, the hash of the password, because on your device you don't store the password in raw format, it is the hash that is stored. If you were on a Linux operating system, the files of interest to the attacker would be the etc shadow and the etc password. So let's have a look at what the etc password file looks like. For this, I'm going to pull up my Kali Linux, and then I'll open the terminal. Just clearing the terminal right now. I would do a cat etc password like that, and there in the terminal you have the list of all user accounts that are currently on this virtual machine. And if you look at the bottom here highlighted, you'll find the very account that I'm using right now. This is the username Kali. This X is some symbolism for the encrypted password, but because Kali understands that the bad guys will be after these passwords, the passwords have been hidden in another file, etc shadow, which we will visit in a bit. The number 1000 here is the user ID of the current user on the system. Immediately after the semicolon, you have another 1000. This other 1000 is the group user of this group within which this user is found. And you also have the shell that this user uses to log in. It is the home Kali user bin ZSA shell that's being used here. I'm going to try to catenate the content of the etc shadow file, and for that I will do cat etc shadow like that. If I try to do this shadow like that, you see the first time I'm denied access. Why? Because this file contains sensitive information, which are password hashes. So I would have to be an admin user to be able to consult this file. For me to do that, I'm just going to do sudo. That's to say, give me privileges as an administrator to be able to do this. And so I'll do cat again, etc shadow like that. And this time around, I have access. And if you look at the bottom line here, you see that I am logged in as Kali, and this long string that you find highlighted is now what the hash of my password is. So if an attacker was after my credentials, they'll be looking for this file. Again, when we discussed hashing, we saw that this hash, you have no way of knowing the password behind this hash except you have like a dictionary of precompiled passwords that you can compare with this. Okay, and to defeat this we can use salting. Now next stop, we are on we just finished with discussing about the presence of sensitive information in the etc shadow file. Hashes generally convert the passwords into fixed length outputs, and these fixed length outputs have these important characteristics. They are deterministic, and what that means is that every text has a unique hash. So if you were going to hash a particular text with a particular hashing algorithm, it's going to give you one and the same hash always. The second characteristic is that this is non-reversible. What this means is that you cannot go from the hash back to the password. So if you have the hash, the only way you can know if you can know the corresponding password is to have maybe like a list of passwords and then try this hashing algorithm on each of them and then compare the hash that you got with what you were given initially. If there was some sort of a match, then you can guess that this is the password of interest. There is the other interesting property about collision resistance. What this means is that if you have two different passwords hashed with the same algorithm, then the hash values will be different. Some common password attacks are the brute force attack and the dictionary attack. How does the brute force attack work? So with the brute force attack, you proceed by guessing passwords and trying to log in with them. So you just guess a password, you go to the prompt when you requested a password, you plug this in, and then you try to validate. If this works, then you got it right. If not, you try one more. And there are programs that have been written that can try this millions of times until you get one correct password and you get logged in. A smart way to stop this will be to do rate limiting. That's you can limit the number of the number of login attempts that can be done. So if someone tries to log in more than 3 times, you can freeze the account. That's how you can deter attackers that are using brute force attacks, for example. The related password attack type that you can have that goes with brute force is what we call the dictionary attack. In the dictionary attack, you get to try out to see which password is the correct one for the account. But this time around, there's a file that contains a list of passwords that we can call candidate passwords that may be used against this account. So basically, the program this time around goes to the file and takes each password in the file and tries to log in with it until eventually it gets the correct one. The approach to protecting against this is pretty much like that for protecting against brute force. You can do rate limiting, but on top of that, you can also add a second factor of authentication so that if someone guessed the password, they will be prompted to enter the second factor of authentication, which chances are they may not have. We've talked about a couple of these mitigations already. Some other mitigations could be to increase the length of the password. If you increase the length of a password, uh, brute force algorithms are able to generate passwords that are up to 8 characters long. And after 8 characters, the brute force algorithm freezes or is not able to generate new passwords. So the tendency is if you got like a password that's between 9 characters and 12 characters long, then the brute force may not be able to do this in compute time. And so this serves as a kind of defense mechanism against brute force attacks. Um, you can also use captchas. And what captchas are, they are basically these mechanisms that go along with logging systems whereby after you've entered your username and password, you'll be expected to solve a problem to be able to validate that you are who you say you are. This problem could just be maybe rotating an image. It could be finding an image with a certain description to be able to move through. Password spraying. This is another type of attack that uh, comes across that we encounter often. Now, with password spraying, the attacker uses a password that they have guessed, and they try to log in to as many systems as possible with this password. Chances are that one of the accounts that this attacker is trying would have this password that the attacker has chosen as their password of interest. How did the attacker get hold of these passwords? They go to platforms like the dark web, and then they buy a list of harvested passwords. These passwords were harvested from uh, password breaches or data breaches, and then they can try this. Chances are that this password is a common password that many users feel is secure enough for them to use. So the attacker keeps trying this until one of the computers within the thousands of computers that they were aiming at is able to accept this password. Then they know that they've succeeded, and then they can use this particular device to cause further harm to a system. So, how do you prevent against password spraying, for instance? An approach to preventing password spraying would be to enable Active Directory password protection. Active Directory gives the user of a domain the possibility of configuring a password policy that has to validate the password against a certain number of criteria. For instance, there's the length criteria, where the password might have to be at least 12 characters long. And then there is the complexity criteria, where the password would have to have special characters like the @ symbol, the hash, the underscore, mixed with numbers, uppercase and lowercase. Also, within Active Directory, you have the possibility of uh, activating password expiry so that a user is able to use a password and this password expires after a period of 3 months, for instance. So if your password has been set to expire in, say, 3 months, and the attacker happens to have this password in the fourth month, they will not be able to access this account of yours because this password has expired. So they would have to try to find the updated password just to be able to, get hold of your account. Another interesting type of attack this time is the category of attacks that we call them application attacks. One of those attacks within this category is what we call the SQL injection attack. The SQL injection attack is used by the attacker, and they seek to compromise the database that is associated with the application of interest. Each time you're logging into a website or into a computer or an application, you are providing it a username and a password. And the application takes the username and the password and strings this into a query that it throws at the database, and it returns from the database a record that contains the username that you provided and the hash of the password that you provided. Now, attackers understand this mechanism. So what they try to do is they try to beat the system by playing on the query that gets generated. Uh, the approach often is to throw in a password or a username that has special characters. These special characters can comment parts of the query, forcing the mechanism to validate the, the other fraction of the query that the attacker is interested in. And that way, they will be able to get what they want. For an example of how this operates, let's take a look at this website, um, hacksplaining.com. So under hacksplaining.com, we have a couple of vulnerabilities that we could be interested in. In this case, we're interested in the SQL injection vulnerability. So if we took this, we can play about with this, login page. We have a username and a password that we're expected to plug in. Right now, I don't know what the username is. I don't know what the password is, but I can try a few things. For starters, I can try something like user@email.com as my email and a password of just password like that. And then I try to log in. You see what happens? I'm not able to log in because these credentials do not match any of the credentials in the database. But if you look at the bottom of my screen here, you actually see that this is what happens behind the scenes. This is the query that is generated from here. The query says select all records from the table users where the email is user@email.com and the password is password. So now I know how this password, the information that I enter into the UI gets stringed into an SQL query. So I'll be keen now to, you know, try to force this application to generate a query that looks like what I want it to do. For this, I would pass in a password that has a commented string in it so that the resultant query that gets generated forces the website to validate this query because this query will be true. In this case, where we actually have a username of user@email.com and a password of password, there's no credential, there's no record in the database that matches this. But if I abused this by commenting part of this query, then SQL will just throw at me all of the usernames and the passwords that are in the database regardless. So this time around, this is what I'm going to do. For the username, I would do user@email.com, and for the password, I would put a password like this, inverted commas open, or 1 is equal to 1, and then dash dash. This dash dash, what it will do is that it would comment the rest of the SQL query. If I try logging in with this, see what happened now. The query that gets generated is select star from users where email is user@email.com and the password is some empty string. But what has happened? The rest of the SQL query has been thrown away, but surprisingly, I got locked in. So I'm able to go ahead and initiate some transfer. This is happening because of the SQL injection vulnerability that is on this application. There's lots of websites out there that have the SQL injection vulnerability on them. So a smart attacker will keep doing these trials to figure out that this application is vulnerable to SQL injection. And the moment they figure out that this application is vulnerable to SQL injection, they can try to manipulate the query and comment part of the query, and they will be logged in without knowing the correct username and password. This is really dangerous. So how do we protect against this? You realize that to be able to get to this point, all we needed to do was we kept putting usernames and passwords, guesses. And then at some point, we actually put a password with some special characters in it. So if we were able to get this application to filter the characters that we put in the username and the password field, and then pick out these sensitive characters, then we would have succeeded. The aspect of filtering the username and password entries to grab special characters and remove them is what we refer to as uh, input validation. So that's one of the important mechanisms or approaches that we use to actually carry out defense against SQL injections. Another approach is to do what we call prepared statements. Prepared statements actually work like this. They work like a second layer of defense. In the event where input validation failed, prepared statements will kick in. What prepared statements do is when they grab, we have already written functions for querying the database, and these functions cannot be modified. So basically, from the user input, the only thing that gets taken is the username and the password, and we plug this straight into SQL statements that have already been generated. We are not the ones generating the SQL dynamically. It's the dynamic generation of SQLs that give the attacker the possibility to comment part of the SQL and force it to behave the way he wanted. But if we have prepared statements now, then we have technically removed the dynamic generation of SQL statements, and the attacker does not have control in such a scenario. Cross-site scripting also is another interesting vulnerability that occurs on most websites. So with cross-site scripting, the attacker is able to write script fragments and embed them into a website. And these script fragments are written in often in JavaScript. These script fragments written in JavaScript are able to execute when a user visits the website and forces the user to take on behavior or take on things that the user would not normally want to do. When the user logs in, for instance, to interact with the website, the script might spin up and then force the user to go to a different website, and then in the process steal the credentials of the user, like tokens or cookies, which contain the user's user ID and session ID. And that is all that the attacker needs to be able to navigate any website of interest. So, how do you protect against cross-site scripting? To protect against cross-site scripting, we can use CAPTCHA, and we can also use SEMS. So you know what the SEM is? SIEM. What that is it's able to pull logs about interactions with the system of interest, and then we can look at these logs and see if there's been any attempts to inject scripts. The way we know if a script has been injected is if in the logs we find instances of of appearance of the script tag. In those instances, we can generate an alert that such transactions should be blocked. If these transactions are blocked, then the attacker is kept out of the system. The last type of attack that might be interesting to consider in this series is what we call the buffer overflow attack. Transactions that happen within a system are usually stored in temporary memory or temporary data structures that we call buffers. So when you plug in things like your username, you plug in your password, if you were booking a hotel, maybe the reservation number, the the room number, and all of that bit of information goes into a buffer, and then this information is forwarded to the back end and then processed in accordance to be able to validate the transaction that you are taking on. These buffers are of fixed sizes, and while interacting with these buffers, the application is supposed to check to ensure that the quantity of information that has been submitted to be put in the buffer is equivalent to the size of the buffer. But it is common practice that some programmers would overlook this aspect and let you write in just any quantity of data into the buffer. If you find yourself writing into the buffer more data than the buffer is able to handle, this can bring about unwanted behavior. And the unwanted behavior can lead to things like, for instance, uh, querying of the database and then providing more information than would have been required. And the attacker takes this to their advantage and they can do lots of things with this. To see how the buffer overflow works, again, we would jump to this application that I shared earlier, head on to lessons, and then scroll down to buffer overflows. So in the buffer overflow section, we're just going to take it one step at a time. I already explained what a buffer is. So the first page here is just telling us what a buffer is. And buffer overflows are common when we use programming languages like C and C++ for building our application. So a smart thing to do is, unless the application can only be built in C or C++, if you are intending to guard against buffer overflows, then you might want to stay away from applications that are built with C and C++. So I'm going to try to type a username because I'm requested to enter a username. But if you see on the right, on the left-hand side, we actually have a buffer of size 8. So when you enter a username, it scans this and puts it inside the buffer and then prints out whatever is in the buffer. So for starters, I will put a username like test. And then the username, it now tells me the username I entered was test. Test, that was just 4 characters. Let's try something crazy and enter say 12 characters. Did you see what happened? There was a segmentation fault that was generated because I put in more characters than the buffer expected. So there was unusual behavior that happened. This unusual behavior is as a result of the abuse of the size of the buffer. If this were happening on the website of a hotel, for instance, this unusual behavior could end up just extracting all the information that's on the database and then dumping it on the browser. And the attacker will have access to possibly all clients that are currently lodged in the hotel. And that's not good. That's something that we want to guard against. So for the second part of this session, we were meant to cover Kali, some hands-on activity on Kali. We did already take some time to see how we can pull up the interesting files in Kali where passwords get saved, like the etc password and the etc shadow. This time around, we're going to learn how we can start the Nessus vulnerability scanner. And for us to start the Nessus vulnerability scanner, we just need to type the command sudo systemctl start and then the name of the service of interest, which is Nessus USD, like that. We're requested to enter the password for the Kali Linux, so I'm going to put the password. Once this is done, Nessus is started, but we're in a terminal and we certainly have no way of understanding or knowing if Nessus is actually running. So we can do one of two things. We can use a command from the terminal to see the status of the service of interest, or we can just head on to the browser and test it out. I think the smart thing to do would be to test and be sure that the service is running first before we go and try out the browser. So I'm going to do sudo systemctl, and this time around I'm going to say I want to know if Nessus is running by checking the status of Nessus like that. And if you look at the feedback that we get from the terminal, it tells us a lot of things, but the information that stands out is the following that's highlighted. That Nessus is currently active and running since Friday the 25th, the 4th of April 2025. It's been running for about since 36 minutes. The first time Nessus was started was 36 minutes ago. So that's the update that's given to us. Now I can head to my browser. If I launch a new instance of my browser, all I need to do is do localhost and specify the port number 8834 for Nessus. And then I will be brought to the Nessus login page where I can specify the username and password, and then I'll go ahead to sign in. Once I'm signed in, I'm ready to begin scanning with Nessus. But what am I going to scan with Nessus? I want to scan a particular device. The device of interest that I want to scan right now is this one. So I would bring up Oracle VirtualBox, and then I will start this other device that I call Metasploitable. So if I start Metasploitable by doing a normal start like this, the attacker will already know the IP address of Metasploitable to be able to scan for vulnerabilities on Metasploitable. But since we're just starting a Metasploitable now and we don't know the IP address, we would look for a means to know this IP address so that we can scan for this. There's actually a set of commands that an attacker, if they found themselves on your Wi-Fi, they can run these commands and generate all IP addresses that are currently logged in on your network, and then they'll be able to scan against this. So if I did ifconfig actually on Nessus, I would have access to the IP address. The IP address right now is 172.30.227.78. So if I grab this IP address, I can now head over to, with this IP address grabbed, I can now head over to the Kali Linux instance, and then I'll put the address in here, 172 dot 226.12.5, for instance. If I did this and this IP address were correct, all I need to do is hit on submit. And if I do this, if I submit, then I will be able to do a scan on Metasploitable 2. What the scan on Metasploitable 2 will return to me will be a set of all applications on Metasploitable 2 that have vulnerabilities, and these vulnerabilities will be ranked either as critical or not critical. Critical will be the ones that can be abused and then utilized to do further action. The not critical will be the ones that, even if abused, will not give us a lot of access on the system or to be able to, persist any action on the system. So I would stop this video here and I would let you guys give me some feedback regarding how much you were able to do with this video. I mean, this is just like a crash video to accompany the presentations that we were meant to do earlier, because most of you ran into technical challenges earlier on. So let me know how much you are able to do with these videos. So right now I'm going to stop the Metasploitable, and I am stopping the Kali Linux as well.